Okay, so we already know, and you got to know these. I think everybody does. We already know two forms of quadratic functions. What's standard form? What's standard form? Raise your hand. You help me out here. Somebody help me out. Jillian, what's standard form? F of x equals what? Are you sure? Think the two forms, each of them has three different numbers you got to plug in, right? Ax squared plus bx plus c is standard form, right? That's kind of the simplified one. That's where we'd end up if we ever have a quadratic function and we just multiply everything out and collect like terms. Then we just end up in standard form, which is like simplified form. Okay. What's vertex form? Hey, Alani, what's vertex form? What are the three parameters for vertex form? A and what? H and K. Okay, I think we need to do a little quiz over this, because you guys got to know this stuff. I mean, this is stuff you just really have to file away up there. So I'm going to put up let's plan on doing this Friday, we're going to do a little quiz, very short, over all the forms of quadratics. I'm going to give you a little, I'll give it to you tomorrow, I'll give you a little handout of everything you have to have absolutely, you got to know, you got to have memorized. You just got to have this stuff. You can't be looking it up, it breaks your train of thought. So we got to know standard form, we got to know vertex form, which is f of x equals a times x minus h quantity squared plus k. And what's important about this? What are the coordinates of the vertex? H and k. Good. What does a do again? Yep, good. Vertical stretch and compression, right? So it's the vertical dilation factor. While we're at it, let's add and you might want to put this in your notes, because this will be on the quiz also. You got to know, how do I calculate, what's my formula for calculating h and k if I'm starting at standard form? So my formula is h equals negative b over 2a, and k equals, how do I calculate k? Plug it in. F of h, right? So that's how I go from this form to that form, right? Okay, so you got to know those four things. Put boxes around these. And I'm adding another one today. Here's a new one. And this is one that we already know. This is called factored form. Sometimes people call it intercepts form. And all it is that. That's it. That just looks like I factored a quadratic, doesn't it? Right? So it's in the form a times the quantity x minus p times the quantity x minus q. Okay, let's look at an example of something like that. Like, what if I were going to give you, for example, I'm just going to give you an example of a quadratic function. What if we had f of x equals negative 2x squared plus 16x plus, actually I'm going to do minus. I'm going to do minus. Oh, no, that was right. I want to go on the minus there. Okay, let's put that into factor form. What do? Just factor, right? That's all I'm doing. So what do I do first? Okay, what is that? Is it 2? Negative 2. How come it's negative, Gabe? Okay, because the part that's being squared, the dominant term, right, the leading term, the biggest power of x is negative, right? So we're going to end up with negative 2 that we undistribute. What's left behind if I do that? X squared minus 8x, good, plus 15, okay. And then can I break that apart? So that's an x squared. So what goes there and there? X. And what two numbers multiply to positive 15 and add to negative 8? Okay, in negative, right? Negative 5 and negative 3. Okay, so now, what if we were trying to, what if this was a different question? What if the question was, find the zeros of this function? Well, wouldn't we have set the whole thing equal to 0? Right? What would our answers have been? What are the zeros? 5 and 3, right? Because those are, when we apply the zero product property, and we set that factor equal to 0, we get the solution x equals 5. And if we set this one equal to 0, we get the solution x equals 3, right? Okay, well what are zeros? Zeros are the places where the function equals 0. When I say the function, I mean f of x, which is y, right? Where on the xy plane does y equal 0? On the x-axis. So those are also x-intercepts, right? So if we were supposed to find the zeros, that's the same thing as the x-intercepts, right? Well, what's the pattern? The x-intercepts are just the numbers that are being subtracted from x, right? So then doesn't that work here? If I'm using this new form, which is just factored form, what's the meaning? What's the meaning of the p and the q? Right, I've got this other form. Notice that the a is always what's being multiplied out front. Always means the same thing. It's the vertical dilation factor. This time the h and the k were the coordinates of the vertex. B and c are just numbers. They don't really help us very much, do they? Right? But what's the meaning of the p and the q if those are the numbers being subtracted from x? What are those? What did we just say? What were the numbers being subtracted from x? They're the zeros, but zeros are the same thing as x-intercepts, right? Those are the x-intercepts. Okay, so look, if we just pull this shade down a little further, p and q are just the x-intercepts of the function. So that's why we call this factored form, or a lot of times, it makes sense to call it intercepts form because we can see what the intercepts are when we write it. Okay? Make sense? Okay. So that's a new form. But is it really a new form? No, it's what we've been doing. We've been factoring. All we're doing is we're just recognizing that when we factor something, whatever the numbers are that are being subtracted from x, those are the x-intercepts, right? Those are the zeros. Okay? So let's try some examples. And what we want to be able to do today is we're just going to practice two things we want to get to. We want to know how to graph functions in factored form, intercepts form. Super easy. I would say it's at least tied with and maybe even easier than graphing in vertex form, and you'll see why. And then we want to be able to convert between these different forms, but most of that stuff we've already done. The hardest stuff we've already done. Like, for example, if we want to convert from standard form to vertex form, that was 3.5, right? We solve for h and plug it in and get k, right? Or if we want to really try it, we can complete the square, but you don't have to. If we want to go from standard form to factored form, we just did that. We factor. That's all you do is factor, right? If we want to go from, like, vertex form to standard form, all we're going to do is that's PEMDAS. We're just going to simplify using PEMDAS. Whenever we go to standard form from anywhere, we're just simplifying, just PEMDAS. So really, we already know how to do most of this stuff, okay? So let's try some sample problems. Like, what if we're starting with this function that's in standard form, and we want to convert this to vertex form and to factored form or intercepts form, and we want to graph it, okay? Okay, so first of all, how about if we go to vertex form? That's probably the hardest thing we do. It's not that bad. How would we put this into vertex form? What form is it in now again? Standard form. So it's in the form f of x equals what's standard form again?
ax squared plus bx plus c.
Good. Ax squared plus bx plus c. So, hey Alani, what are the values of A and B? Good. B is -4. Good. And we don't even really, I could write down C, but I don't really care about C. Okay. I know that my goal here is I want to convert this into vertex form. Well, we know vertex form. Everybody, once again, what's vertex form? Plus K. Okay. All right, so I just got to plug in values, right? We have to, does everybody see why we need to know what these forms are, though? Because we got to be able to know where we're starting so we can plug values into the correct template. This is the template that we're using for vertex form. I already know one of the three numbers. Which one do I know? A. Yeah, look, A is -2. I already know I'm just going to plug -2 in for A. I just have to know what am I plugging in for H and what am I plugging in for K. All right, Dominic, what's my formula again for calculating H? Very good. -B/2A. So -B would be +4 divided by, hey, phones should, let's have phones put away, please, like completely in pockets away. Okay. Would be +4/2 times -2. What's that? Let's put that away. What's 2 times -2? -4. What's 4/4? -1. Okay, right? 4/4 is -1. So that's my value of H. There's another one we can add to our list. Right? So H is -1. I'm plugging -1 in for H. Okay? Okay, once again, I'd like phones away. I really don't want, do you guys get why I don't want phones out? You answer the question for me. Why don't I want phones out? Because it's going to distract you. Is it going to help you? No. Can you help yourself a lot of times? No. You're addicted to them, so you can't. I mean, you can't help yourself. You're going to look at them, but I'm going to save you from yourself. In here, I don't want you to fall prey to that. So, I mean, you probably already know you're addicted to them. Most people are, but you put them away. I don't want them on your desk. Please put that away. Oh, it's okay. We'll just flip it over then. Okay. So then, what about K? How do I calculate K? Plug it in, right? That's my method for finding K. It's a Y coordinate to find the Y value. Y is the f of x, right? So we just plug it into the function. So K equals f of h. So for us, that's f of -1. So every place in my function up here where I have an x, I'm going to plug in a dump a value. So I open up an empty quantity, and I'm going to plug in a -1. So now we got to simplify that. How do I simplify the first term? What do I do first? Parentheses, but then after that I do exponents, right? So I've got to square this thing first before I multiply by 2. Exponents come before multiplying. So -1 squared is 1 times 2, 2. -4 times -1, plus 6. So what do we get then? We get, that's supposed to be a -2, wasn't it? So I should have made that a negative. -2 times 1. So then I get 10 plus -2. Doesn't that give me 8? That's K. Whoops, not H. All right, we're calculating K as f of H. So K equals 8. So there's the other number I'm plugging in. All I got to do is plug those things in and I'm done, right? So I just get f of x equals -2 times x minus -1, makes that a +1 squared, plus 8. Right? And that's what we did back in section 3.5. We did a whole bunch of that stuff. Right? Probably the hardest section we've done, I would say, was that section. But you got good at it, right? If you did that homework, you got much better at that stuff. So we can do that. That's not that big a deal. What about converting it to factored form or intercepts form? Easier. That's what we've been practicing. So what are the steps we'd go through there? Greatest common factor. Okay, so first thing we would do is factor out the greatest common factor, which is what? Negative 2. And that leaves us behind with what? Plus 2x. And how are we getting this? Let's remind ourselves. All I'm really doing is just dividing by negative 2, right? And that's giving me all these answers. So that gives me that. Negative 4x over negative 2 is positive 2x. 6 over negative 2 is, there you go. Okay, and then last step, we're going to factor that, exactly. If we can. So those are x's. What magic numbers multiply to negative 3 and add to positive 2? Say it again. Negative 1 and positive 3, isn't it? Yeah. We know one's positive and one's negative because they multiply to a negative. The bigger one must be positive because they add to a positive, and the numbers are 3 and 1. Okay? So there, look, that's in the right form, isn't it? That's in the form that we were looking for. That's in the form, factored form, which is just a times x minus p times x minus q, right? Okay? So now what if we want to graph that guy? So, and let's, I'll tell you what, to graph it, let's not use vertex form. We know how to graph from vertex form. Let's graph from intercepts form. Okay, and it's easy. I think it's easier. I'll show you why. So what are the values of P and Q? If we go back over here, what are the values of P and Q? Everybody see that? So the value, if we compare factored form to my answer, the value I would have to plug in for P is negative 3, right? Remember, it's always going to be opposite of what that plus sign is. We're subtracting P from x. So to get x plus 3, we're subtracting negative 3, right? So P equals negative 3. What's Q? 1. Those are my x-intercepts, aren't they? So when I graph this thing, that helps. I've got x-intercepts at negative 3 and at positive 1. Those are my values of P and Q. Okay, what can you tell me about parabolas? About the graphs of parabolas? There's some. What do you think we're going to get at here that's really important? There's a very important property of parabolas that's going to allow us to use those 2 points. Okay, what about that? They go like this, but what's the important thing here? Okay, they're minima and maxima, sure, but what about remember this where we can fold them over each other? What do we call that? What does that mean when objects have that kind of, where you can fold them over and they line up perfectly? Symmetry. Yeah, they've got that line symmetry, the folding symmetry, right? And the line of symmetry is the fold on the paper, isn't it? So what's the x value where the line of symmetry is going to sit? X equals what? How'd you get negative 1? It's in the middle, right? These have to be mirror images. These are, everybody get that? If we're going to fold this thing over, these 2 points have to be reflections of each other, right? They have to be images of each other when I fold the paper over. So it has to, the fold has to be in the exact middle. Just makes sense, doesn't it? Right? So here's the axis of symmetry. Is that line right there, x equals negative 1. Anybody tell me what h is? What's the x coordinate of the vertex? Negative 1, right? Because it's going to be on that line, isn't it? Right? So how do we find then, what's a tricky way? You were able to do that pretty easily here because those numbers are easy to work with. Negative 3 and positive 1, we can see that negative 1 is in the middle. What if the numbers were not so convenient though? How can I always find the middle value of 2 numbers? Average. That's all it is. That's what an average means, isn't it? Like if I ask you what's the average of 20 and 64, you can find it pretty easily. What would I do? What's the average of 20 and 64? What do you do? No? Like how would you, what if I asked you for the average of 5 numbers? What would you do? Yeah, you add them up and divide by 5. So what's the average of two numbers? Even easier. Add them up and divide by 2, right? So I can always find the average value of P and Q. That's going to be the middle value by just averaging those two. So let's add that to our list here. Here's another thing you got to know, which you can add to your list of items that are going to be on that quiz we're doing Friday. We have to know also that H is equal to P plus Q divided by 2. It's the average of P and Q, right? And that's how we go from here between these two, right? Okay? So if that's true, then we know that H equals P plus Q divided by 2. Well, that's negative 3 plus 1, right? Negative 3 plus 1 over 2 is negative 2 over 2. What's negative 2 over 2? Well, negative 1. So H equals negative 1. How do I find K? Plug it in. And where do I plug it in? Do I want to plug it in up there? I could. But wouldn't I rather plug it in right there? You would. Here's why. When it's in factored form, when I plug a value in, it's going to be really easy to find the answer. I'm just going to get negative 2 times that number times that number. That's all I got to do. Multiply 3 numbers together. Easy, right? So if I plug H in, I get f of negative 1 equals negative 2 times that number. What's going to be negative 1 plus 3? 2. So I get 2 there times that number. What's negative 1 minus 1? No. Negative 2. And notice, and this will always be the case, notice that when I am calculating H, because it's halfway in between, notice that those two numbers I get are always going to be opposites every time when I plug H in to find K. And then if I multiply those three things together, it's easy, right? K is just negative 2 times 2, which is negative 4, times negative 2 is what? Positive, what was it again? 8. So my vertex then is going to be at negative 1, positive 8, and I'm done. I got my 3 points already. All I got to do is just connect the dots and I'm done, right? So there's my parabola. Easy, right? Super easy. If it's in intercepts form or factored form, I already know what P and Q are just by seeing what's subtracted from X. That gives me the X coordinate, that gives me the X intercept, so I already have 2 points for free. Then I average those values to get H, plug it in to find K, and we got the vertex. And we got our 3 points and we're done. We got a graph. Okay? All right, what about this? What if we want to, let's try starting. The last example, we started in standard form, and we converted to both factored form and vertex form. Now let's take a different route. This time, let's start in factored form, and let's convert to vertex form and to standard form. You see if you can remember here. So now this is in factored form, correct? Okay, so let's write down what factored form is right next to this. You can remind me one more time, what's factored form?
X minus Q of
P times X minus Q, and what's out front? A. Okay, so then what can you tell me? A is 2, what's P? What's Q? Positive 6. Everybody agree? Okay. So I already know A. I'm trying to put this into vertex form. Vertex form. Jaylene, what's vertex form? F of X equals what times what times what is it? A, good, times X minus H squared plus K. Good. and I'm gonna plug in values. Well, I already know what A is. I'm plugging 2 in there. If P is 2 and Q is 6, how do I find H? Add them and divide by 2. I'm gonna average them to get the middle value. So I'm gonna get 2 plus 6 over 2. Well, that's 8 over 2, which is what? 4. Which makes sense. That's halfway between 2 and 6, isn't it? Right? So we get H is 4. And then how would I find K? Plug it in. Yeah. K is just going to be F of 4, which is 2 times, what's 4 minus 2? 2 times 4 minus 6. Negative 2. So 2 times 2 is 4, times negative 2 is negative 8. Got it, right? So now I know that vertex form is just 2 times x minus 4 squared minus 8. Okay, good question.
For the H, did we just subtract what it says vertex?
No, in this case, it works this time, but it wouldn't work every time, right? Like, for example, what if P and Q were 0 and 4? 4 minus 0 would be 4, but the value should be 2, shouldn't it? Yeah, no, you have to average them. Yeah, just an accident that worked this time. You saw a pattern. Okay, what if we want to convert to standard form? Whenever we convert to standard form, remember what that means. Converting, if we're going into standard form, all that means is PEMDAS. We're just simplifying. That's it. Right? So what are the steps I would follow to simplify this? If I'm going to check the steps of PEMDAS off, what do? Parentheses. Is there anything I can do inside parentheses here to simplify? No. So I can just cancel that one off. Any exponents? No. But I do have to multiply and divide, don't I? I'm multiplying 3 things together. I'm multiplying 2 times x minus 2 times x minus 6. It doesn't matter the order, but I think it'd be a little bit easier to multiply those 2 first and then distribute the 2, don't you think? To FOIL them out and then get an answer and then just distribute the 2. So if I FOIL those out, what am I going to get? Let's go through that process. So I got to distribute the x first. So I'm going to get x squared minus 6x, good. Now if I distribute the negative 2, well hold on, if I'm distributing the negative 2, minus 2x
12.
plus 12. Okay, and if I add up like terms, those combine, right? So I get my 2 out front times x squared. What's negative 6x minus 2x? Good. And then if I distribute my 2, what do I get? Done. Okay, yes, sir. Yep. Right, so that's easy. Converting to standard form just means PEMDAS, simplifying, okay? All right, so what if we want to convert that to vertex form? Didn't we do that? Oh, now we're just graphing it. Okay, well, graphing it's easy, right? In fact, we already did all the work. Look, when we put this into vertex form, we averaged P and Q to find H, which was 4. We plugged that in to find K, which was negative 8. That's all we need, isn't it? Right? So if we go to the graph, it was positive 4, negative 8, right? So we found P was 2, Q was 6, so H is halfway in between, which is 4, and when we plugged that in, we got negative 8. So look, I've got x-intercepts at 2 and 6. My vertex is at 4. When I plug it in, I got negative 8. So there's my function. right? Say it again. The test over this stuff, we're gonna do one more topic after this one, and then we'll do a test. Okay. We're gonna break up this chapter into 3 parts. It's a big unit. Okay. How about this one? Last possibility. Now we're gonna start in vertex form, and we're gonna go to the other 2, right? So vertex form to standard form. Well, what do we say if we're converting to standard form? What are we doing? If we're ending up in standard form, what does that amount to? What do we say? If we convert to standard form, it's just PEMDAS. We're just simplifying, right? We end up in standard form, that's just simplified form, where we're just going to multiply everything out and collect like terms, right? So same thing here. If I'm converting to standard form, that's PEMDAS. And so I'm simplifying. I'll go regular, start at the top and work my way down, simplifying. So what do I do first? Can I do anything inside parentheses? No, x plus 4 doesn't, they don't combine. They're not like terms. Do I have exponents? I do have exponents. Look, I've got an exponent right there. So the first thing we have to do, call that step 1, is we have to figure out what is x plus 4 squared. X plus 4 squared, isn't that just x plus 4 times x plus 4? So we'll just FOIL it out, right? So that gives us, if I distribute the x, what do I get?
X squared 16.
Plus 4x. And if I distribute, because I'm going to distribute the x to the second factor, and then I'll distribute the 4. So 4 times x is another 4x. 4 times 4 is 16. And then when I add up those like terms, what's 4x plus 4x? 8x. So, okay, so then this part right here, I'm going to put this in a box. Right? We did that work, and we found that x plus 4 squared equaled x squared plus 8x plus 16. So that's just step 1 though, right? So now we know f of x equals -2 times this whole thing, because we squared out x plus 4. Whoops. Does everybody see that I have to have that in parentheses? How come? Why do I have to put parentheses around that? Because I haven't distributed. Good, right? Because what's the next step? The next step is multiply. What does multiply mean? In this case, distribute. I got to multiply the -2 times whatever I got there, don't I? Well, I have to multiply it by the whole thing, so I have to put it in parentheses. So when I distribute the -2x, what do I get? -2x squared minus 16x minus 32 plus 18. So multiply was my second step. What's the third step? Joseph, what's the third step going to be then? Now what do I have to do? Work my way down. We did the exponent, we multiplied, what's next? In PEMDAS, we're just working our way down. Well, if we had to divide, we would. You're right, but do I need to divide anything there? What's the only thing left I have to do to simplify that? There you go, add like terms, right? So step 3 is just going to be, we're going to add or subtract, whichever one we end up having to do. In this case, we're just adding like terms. And so my final answer just looks like -2x squared minus 16x. What's -32 plus 18? I'm going to get a negative result, right? 14. There you go. So there's my answer. All I did was PEMDAS. That's it. Okay, you've done that for years. Okay, the second part though, we want to convert this into intercepts form. Okay, so how would we go about doing that? How are we going to convert this into intercepts form? This unfortunately means I've got to put this into standard form and then factor it, right? But we already did that part, didn't we? We've already got standard form right here. How often are we going to do this? Not very often. Not very often, but we just want you to know how. So here's We already did the work to get it into standard form. So we already put it into standard form, right? Once we get it in standard form, now we just factor it. Okay, so what am I going to do first to factor it? Nancy, what's the first step? Oh, no, you got this. What do we always try to do when we're factoring first? Right. Yeah. Right? We always want to try to get out a greatest common factor first. See if we can undistribute something. What's that going to be? What can I undistribute from each of those? There you go. And in fact, it's going to be a -2, isn't it? Right? So there you go. So first step is we're going to take out a -2. And that leaves us behind with what? I'm just going to divide each term by -2 to see what's left over. So what's that term going to give me if I divide by -2? X squared. What's that term going to give me? Plus 8x, and what's that term going to give me? Plus 7. So now the last step is I just have to factor that guy, right? So I've got -2, and those are x's. What magic numbers multiply to 7 and add to 8? Got it. Right? We got this stuff. It's not that big a deal, is it? And the last thing would be to graph it. And why wouldn't we maybe just graph it from either from factor form, or we could graph it from our vertex form, right? Okay? You got this. That's what the next assignment is about. The next 2 assignments. First assignment's about 4.3 practice 1 is about converting between forms. 4.3 practice 2 is just a few practice problems graphing functions in factored form.